Hi all, welcome back to Technocraft. Python for beginners. Hope you are enjoying the course so far. This is the second module of the course, and in this module we are going to get our hands dirty and see some Python coding. In this module we'll take a look at Python built-in data types such as integers, strings, Boolean, and flow control systems like if. We'll throw in some try and except into the mix so we can see if our code will execute and if needed, handle something called exceptions. Of course, Python has a lot of other built-in data types like tuples, sets, frozens, etc. My hope is that by end of this module, you will be familiar enough with the basics Python data types that you will be able to learn the rest of them by yourself. In the end, you will see that you don't really have to worry about data types in Python as much as you do in some other languages. Namely, you don't have to declare a type of variable in advance. Python will figure that out for you. There are some advantages and some disadvantages to this approach. So let's take a look. So I named these video types in Python because I feel that the way Python handles types is different from a number of other programming languages. In many programming languages, including Java or C, you have to declare a variable type before you declare the variable itself. The variable type can be an int, float, a string, a char, a bool, and many others, or your own custom type such as a student. So before you even declare a variable, you have to write something like this. Granted, some other languages allow you to omit the it part or the type part in general and simply write var and then the compiler will figure out the type for you. But this is not always applicable. Python takes this approach in the opposite direction. With Python, it is not necessary to declare a type anywhere. In fact, you declare a variable like this. The same thing goes for any other type, including your own type that you will create later on. Aside from that, Python simply does not have as many types as C or Java. We don't have to deal with longs, doubles, unsigned or signed integers, shorts, etc. Now, there are certain advantages and disadvantages to this approach. The jury is still kind of out on that one. For example, in languages like Python that do not require you to declare types up ahead, also called dynamically typed languages, many argue that it simply speeds up the development time. You do not need to spend a lot of time worrying about types. This may not seem like a huge obstacle with built-in types or in the beginning, but it becomes somewhat burdensome when you are dealing with a plethora of your own custom types. It simply makes the language a bit too verbose, but there is a problem. Not declaring types up ahead can lead to a fair number of early and subtle bugs. For example, let's suppose that we have a simple function that adds two numbers together. That function will look like this, right? Now, this function call should work just fine, right? And it does. But what if we call it with a string like we had written on the second statement? We get a Python type error telling us that it cannot add an int and a string or an integer and a string. Python does not really have a mechanism to tell you this in advance, whereas in other languages where you are required to declare types called statically typed languages, the editor itself will usually tell you before you even run the program, or the compiler will simply fail to compile the program if an error like this occurs. So the program wouldn't even run. Now, there is something called type hinting in Python. This is a relatively new feature added in Python 3.5 that can help you add data types to your Python program. However, not that is that this is essentially just helping Python editors and IDEs. It's not going to prevent you code from running if you put a wrong type. Merely your editor will just tell you. While this is definitely helpful, it is far from a full out replacement for a completely statically typed language. How do I deal with this? I try to write a lot of unit tests with Python phrase more so than with other languages. I throw in all the different data types into the mix and expect a large chunk of my unit tests to have their assertions fail. Whether this is the right approach or not, well, this has been a part of an ongoing debate for decades. So let's take a look at some of the basics Python built-in types, and since we already talked about them, let's start with integers and floats. Integers and floats, put simply, integers are numbers and floats are decimal numbers. Defining integers or any other type in Python for that matters is very easy. Simply type the variable name and assign it to a numerical value. That's it. Integers are numbers that can be positive or negative or zero, but they cannot have a decimal point. They have an unlimited precision and support all kind of mathematical and arithmetical operations such as addition, subtraction, getting a reminder, absolute value of the number, and more. Aside from integers, we also have floating point numbers or floats, which can be decimal. The two support the same operation as integers. Python 3 also introduced complex numbers as a type. Remember, though I said that there is no real need to worry about types in Python, at least not in the beginning. You can seamlessly add integers and floats if you would like to. And Python is not going to complain about you adding two different types and whatnot. It will pro- produce the desired result. So normally you don't even have to think about the fact that whether or not a number, if an integer or float, just go ahead and do whatever operation you want with it. Integer type is int and floating number type is float. This is great because we can use these types name to convert or cast variable to an integer to a float when we really need to. Simply surround your variable with int or float to convert it. Be aware of those little values error that can arise if you are trying to convert something that clearly not a number to say an integer. What comes right after the number? Why text, of course, or a string? Strings. We use strings to represent text. By default, it's Unicode text in Python 3, but ASCII text in Python 2. And this is for me um, one of the biggest advantages to upgrading to Python 3. By the way, strings can defined using single quotes, double quotes, for three times the quotes, either single or double. There is absolutely no different which one you use. You will often see though the three times quotes are used as a functions or a class documentation. Yes, although we use the pound key to have comments in Python, we don't have anything like multi-line comments. Interestingly, but it is perfectly acceptable to just put a multi-line string using these three times quotes. But that string is not going to be assigned to any variable. It's just going to be sitting there as a comment. In fact, your editor will even recognize it as a comment. Again, defining string is super simple. Just type a variable name and assign it that textual value. Strings in Python supports a lot of methods, including a lot of useful utility methods. Some of them are capitalize, which will make the first character a capital letter, replace with which takes two arguments, the first one being the character to be replaced and the second one is the character to replace it with. Then we have is alpha or is digit, which will return true if all characters are letters or digits respectively. A couple of other methods you might find very useful when dealing with strings in split, which also takes one argument, and format, which takes a variable number of arguments. Split function is called when you want to split certain string into a list using a chapter you specify as the argument. This can be useful when you receive some data as a string, but as a matter of fact, you see the data as the list of values separated by a comma, tab character, pipe character, whatever. String format is normally used when you want to replace existing text in given string with a variable value. You'll see it at the end of an existing line of text. For example, let's say we have a variable called the name defined as Python bio and machine name defined as HL. But those variable values can change at any time. We can have a different name or a different machine, yet we still want to print that message that says, "Nice to meet you. Name, uh, I am machine." In order to do that, we have to write the code that looks something similar like this. This looks a little bit weird, doesn't it? What what you should know is that the variable name and the argument 0 go hand in hand. The number 0 here indicates the position of the argument in our format function. So since we have names as our first format argument and Python is 0 based, so first actually means 0th. We put the number 0 in our sentence, so that evaluates to name. Similarly, we put the number 1 so that it will evaluate to machine. We can keep going on with this forever. In fact, we can put 0 again anywhere in our sentence, and it's all going to refer to the same. You can add as many arguments as you want to the format function, but wait a second, how can you add as many arguments as you want to any function? Don't worry. You'll learn that soon enough. Format is a pretty powerful function. It supports padding, printing, class attributes, and much more. In fact, there is an entire website dedicated just to the format function, neatly documenting all of its use. Python 3.6 did introduce string interpolation though, so now you can do something like nice to meet you, braces name, my name is braces machine. Not that these are directly variable names themselves, but you have to prefix the whole string with the letter F outside of the string itself, in front of the string. Though there is not the only time you use a character in front of a string in Python. There is also the letter R to denote a row string so that Python does not automatically escape backslashes and whatnot, or the letter U to tell Python to that is a Unicode string we are dealing with. Which one you should use? The choice is always yours. I personally like a string interpolation, but like I said, the format function is pretty powerful. All this time, and we only want through integers and strings, and here I was saying how simply Python is. Right. Don't worry, I'm just trying to build your knowledge from the ground up. There are some other interesting interesting string properties like string slicing, but I think you had enough of strings for now. Let's move on to Boolean and none. Boolean and none. I promise this clip will be simpler than the last one. Boolean indicates a true or false value. You can assign any variable to be true or false. And declaring a variable as a Boolean, what do you do? Guessed it. It's simply type the variable name and assign it. True or false. Boolean is most often used with if statements or when you are trying to set a flag for something like has this task has been completed yet? Yes or no, or true or false. One thing to note about Boolean in Python compared to most of other programming language I have deal with, this is they both start with capital letters, true and false. Interest Interestingly enough, you can convert a Boolean to an integer and it will give you a value of 1 or for true or 0 for false. But no, however, the converting true or false to a string will simply give you a textual representation. So a string with the value true or false. None is similar to null in another languages. It denotes that a variable has been defined so that as the developers have typed the name of the variable somewhere, but that it is not associated with any value. We found no alliance so far. Well, at least at the time of recording this course, I guess. I find it useful sometimes as placeholder variable, something that I will use later, but I don't have a value for it right off the bat. It also evaluates to false in an if statement, so that can be useful as well. However, there is difference between a non-variable and a variable that you have not defined at all. Simply typing say k in the ideally will produce a name error saying that k is not has been defined. But if you assign a none to say aliens underscore found and type it, it will not give any result, which is normal for none, but it will not cause any errors to show up either. The type of none is called none type. Now let's take a look to see how we can use these beauties in if statement. If statement, we have gotten to the if statement. If statements in Python are very simple. This is what a normal if statement looks like in Python. Now is as good a time for a reminder as any. Remember, the Python use intention instead of curly braces for any code blocks. This includes if statements, loops, and functions as well as we'll see later on. Notice also that our if condition and our else both end with a colon. This is also a requirement in Python. We use the double equal sign to check if equality in Python. We also sometimes use the keyword it to see if two variables are pointing to the same object in memory. In this case, we have an equal check. We are asking if the variable number is equal to 5, which it is. This if statement work as it should. It will print the number 5 to the console. Let's suppose that you just want to check if variable has a truthy value. Python has this concept of truthy and falsy value. For example, any number other than 0 has a truthy value that includes 1 to 50 or 30000000, whatever. Similarly, a string that has any value or any text. So as long as it's not an empty string, also has a truthy value. This means that the truthy integer and the truthy string will evaluate to true, and as such, our if statement would pass. When you are dealing with list, which is similar to arrays, and we will learn them pretty soon in many languages, you have to check the length of the list and see if it is greater than or equal to 0. In order to put it an if statement with Python, you could just write if, let's say, student underscore list. So you will just have if student underscore list. Many times you will find you don't really care about the value of a variable in an if statement. You just want to make sure that it is defined. So in that case, you will write something like this that you see on the screen. Now, maybe the number of text value will change over time, but we don't really care. We need to execute the two if statements every time their condition have a truthy value. There is no need to do if numbers is not equal to 0 just to check and see if the number is defined or not. I mean, why would you, if you keep it simpler and do it this way? You will see some other programming languages having utility method, especially on strings, called is null or empty or just is empty or similar. There is no need for this in Python, of course. The same can be said for Boolean and none. If you have a Python underscore course equal to true variable defined, there is no reason for you to do anything along with lines if Python underscore course equal to true. That's just silly. Simply typing if Python course is enough. The none type we discussed in our previous session has a falsy values as you might assume. So if the variable has a value of none, say aliens underscore found, aliens underscore found equal to none, the if aliens underscore found will not execute because this condition is not true. Rather, it will skip this if block or hit the else block if one was defined. To do an opposite if check, meaning to check and see if your condition is false, you normally use the not equal sign and sometimes is not as a counter to this mentioned earlier that allows you to not have to write an empty if condition and then just put your code you expect to execute in the else block. Additionally, when checking to see if a value is truthy or falsy, you can prefix it with a keyword not. You'll see this very often when it comes to dealing with the Boolean and none. What else? You can also check for multiple if conditions in one line, generally using and or keyword in Python. No, they're not double they're not double pipes as in many other languages, but rather just words and uh, and or. The way it works with this with and is that both variables to the left and to the right of the and need to have a truthy value. Only then we will only then will the condition will be true and your if block will execute. If one of them fails, your if statement will not execute. With or one of the two variables on either side need to have a truthy value. The other variable can be falsy. If they're both falsy, your if statement block would not execute. You can add as many as variable you want to your if statement, although it's probably the best idea to not keep the list of variables too long. Python Python does support one line or something called ternary if statements. If you have used other programming languages, you have probably seen questions marks sometimes thrown in the middle of an if statement. Python works a little bit different. Let's say we have two variables, a is 1 and b is 2. And let's say we want the text bigger to display if a greater than b or smaller if a smaller than b, and we could use the normal if statement, but we can save ourselves some space and write it this way. We see that we get similar because 1 is smaller than 2. So let's analyze our if statement a bit. All we really did is rearrange the position of our condition check and the output in our code. We still have our condition a is greater than b and our action in case is greater or else. Really try to read this in a broken English. Instead of reading it as if a is greater than b, then bigger or smaller, try to read it as bigger if a is greater than b, else smaller. Although they may look useless, they can actually be pretty powerful tool, especially when dealing with the list comprehension. And speaking of list, let's take a look at them in the next session. And thank you all. We will see you on the next module.